Hello class, Dr. Vance here. So let's continue our discussions on the properties, on the properties of Fourier transforms, So this shall be I think this should be the part 6 of this particular lecture, okay? And then we're going to consider the Parseval's property. The Parseval's property is a very important one, okay? It's a very important one because it gives the energy of the signal in the time domain and in the frequency domain, okay? So let's go into this. Okay, so now here, if x1 of t has a Fourier transform, okay, Fourier transform of x1 of omega, and x2 of t also has a Fourier transform of x2 of omega, then what I'm going to have is that I'm going to have this particular property that the integral, okay, of x1 of t, okay, into x2 of what? T. Here is a complex conjugate. It's also going to have a Fourier transform of 1 on 2 pi into minus infinity and then infinity. Okay, x1 of what? Omega into x2 of omega. Here is the complex conjugate form. Okay, here is what? The omega, and here is the t. Alright. So now, what I'm going to actually write it is that I am going to make it in this particular format. Okay. I'm going to say that this particular x1 of omega, I'm going to put the inverse Fourier transform of it over there, okay? And that's going to be the same, all right? That's going to be the same. Okay, so now, if I have that, then to be able to write that, I'll say that this particular format, okay, this particular format I have here, I'm going to write it this way. I'm going to write a Fourier transform of it, okay? So here, minus infinity to infinity, okay, x1 of what? T into x2 of what? T, okay, complex conjugate, okay, it's going to be equals to, I'm going to write this particular place, I'm going to write the inverse Fourier transform for the s1 of t. So here, I'm going to maintain this one, okay, minus, I've maintained this integral over here, and then I'm going to write the inverse Fourier transform of this one. The inverse Fourier transform of this one. Alright. So the inverse Fourier transform of this one is going to be what? It's going to be 1 on 2 pi. Okay. Integral infinity minus what? Infinity. Let me bring bracket here. Okay. So here is going to be what? X1 of what? Omega. Okay. That is, I'm writing the inverse Fourier transform for this one into what? E j omega what? T. Oh yes. E j omega. Omega t. So here it will be what? The omega. Okay. And then I'll close it. And then I'll bring what? This aspect. And then this aspect is what? This aspect is actually going to be what? X2 of what? T, and it's a complex conjugate. Okay. So it's what? The t. Okay. So that is what I'm going to have. Okay. So now if I have that one, then what is it going to give me? Okay, so then it's going to give me such that I can rewrite these terms in proper clearer terms. Okay, so in proper clearer terms, to separate the integrals. Okay, to separate the integrals, so I can have infinity minus infinity. Okay, and then I can have my 1 over 2 pi here, and then I can have my x1 of omega. X1 of omega, the omega can come here. Okay, and here I can have this one also. Okay, this integral for actually here. Okay, so then if this integral can come here, so now here x2 of what? Of t, and then I can have this one like this, ej omega of t. Okay, and here is the what? The t. Okay, here is the t. All right. So now, if I have it in that way, then what I can say is that if I have it in this way, okay, then what I can actually have it is going to be this way. Okay, it's going to be this way, such that this particular format is the what? Is this one? Sorry, is the what? Complex conjugate. Okay, is a complex conjugate. Okay, so now I want the complex conjugate to come outside so that I can get this one to be negative. If the complex conjugate comes outside, it affects the whole of this one become negative. So I can rewrite this expression in this particular format. Okay, in this particular format, x1 of what? Omega. Okay, the omega into this particular format, minus infinity. Okay, I can say that x2, okay, x2 of what? T into e j, now I'll put minus here, omega what? T, okay, ej omega t, okay, and then I'll bring the what? Bracket here, and then I'll bring the complex conjugate here. So now you see that here is minus, okay, because I brought the complex conjugate outside. If you bring the complex conjugate outside, here becomes minus. You see that here it was positive, but now it has become minus here because I brought the complex conjugate outside. If you bring the complex conjugate outside, this positive becomes minus, and then I can bring my what? Dt. Now you can see that this expression here is basically the Fourier transform of x2 of what? T. In that case, I can now say that 1 over what? 2 pi into what? Integral infinity minus infinity into x1 of what? Omega. Okay, into x1 of omega. Okay, so here now becomes what? X2 of what? X2 of omega. All right, it now becomes x2 of what? Omega. Okay, which is the complex conjugate. Okay, this complex conjugate. Now I can have it here. Okay, so now if I have it, everything is in omega, so now the omega can come here. There will be no more dt. Okay, so now what you can see is that this expression I have here is the same thing I have what? Over here. So it is basically what? Proving. Okay, so now you can see that it is now basically what? Proving. Okay, so now let's also imagine a case whereby if x1 of t is equals to x2 of what? T is equals to x of what? T. Okay, then I can have infinity minus infinity. Okay, x1 of t into what? Sorry, I'll not write x1 of t. Okay, I said it's equal to what? X of t. So sorry, I'll write x of what? I'll write x of t into what? X of what? X of t. Okay, so this is the complex what? Conjugate. Okay, is equals to 1 over what? 2 pi into minus infinity into what? Infinity. Okay, so here x of what? Omega into x of what? Omega. Okay, here complex what? Conjugate. Okay, so this is basically what I can have here. Please, here is the t and here is the what? Omega. Okay, so this is basically what I can have. Okay, so let me rewrite it here well for you. So it's what? Infinity minus infinity, x1 of what? T, x omega, okay, of what? T. The t is equals to 1 over what? 2 pi into what? Yeah, x of what? Omega into x of what? Complex conjugate, okay, of what? Omega. Okay, so now basically what you can see here is that this is what? 2 squares. Okay, this is 2 squares. So I can say that infinity minus infinity, okay, x of what? T, okay, is 2 squares, okay, which is equals to 1 over what? 2 pi. Okay, so we take the modulus so that whether it is positive or negative, we can take it. Okay, so that we can consider both negative and positive. Okay, infinity minus what? Infinity x of what? Omega. Okay, here like this. Okay, here. Okay, basically this is what we're going to what? Get. Okay, so please, here is t, so the what? The t. Here is omega, so the what? Omega. So basically this is what we get. Okay, so now when we have this one, then what we can actually say is that we can be able to deduce the energy, and then we can be able to deduce the energy and then the energies from it. Okay, so now in terms of energy in the domains, so let me rewrite the equation that I got again. Okay, so this is what I actually had. So I had infinity minus infinity x of what? X of t, okay, squared. Okay, the t is equals to 1 over 2 pi into what? Infinity minus infinity, and then what? X of what? X of what? Omega. Okay, squared the what? Omega. Okay, so this is what I had. So now this particular aspect, okay, which is this particular aspect, which is integral, okay, like this, x of what? T squared the t. Okay, basically it is called the energy, or it gives the energy of the signal in the time domain. Okay, so this one, let me write here, gives okay, the energy of the signal. Okay, it gives the energy of the signal in the time domain. And this particular aspect you see here, okay, which is integral infinity minus infinity, okay, x of what? Omega, okay, squared the what? Omega. Okay, this particular aspect you see, okay, gives the energy of the signal in the frequency domain. Okay, so these are the two scenarios that you're going to what? Have. Okay, these are the two scenarios you're going to have. And then when you have x of what? Omega, x of omega. Okay, when you have please, here I'm supposed to bring 1 over what? 2 pi. Okay, sorry about that. I'm supposed to bring 1 over 2 pi there. Okay, just as it is here. All right, just as it is what? Here. Okay, so I have to bring 1 over 2 pi here. All right, so now when you have this one, this expression, okay, this expression actually also gives the energy spectral density. Okay, it gives, or is the energy, gives the energy spectral density. Okay, the energy spectral density. And when we say the energy spectral density, what it actually tells us is that the distribution is the distribution of the energy over the frequency. Okay, over the frequency. So thank you so much. So this shall be the end of this particular lesson. We shall go to the next one in the next lecture. Thank you so much.